I'm told that this number is correct to one decimal place. So the upper bound is 4.85 and the lower bound is 4.75. This number is correct to two decimal places. So the upper bound is 2.385 and the lower bound is 2.375. I then need to calculate, first of all, the lower bound for A. For this to be as low as it possibly can be, n needs to be as small as possible and d needs to be as large as possible. So the lower bound for A is going to be the smallest n, which was 4.75, divided by the largest d, which was 2.385. This gives me 1.9916 correct to 5 significant figures. I now need to calculate the upper bound for A. For this to be as large as possible, n needs to be the biggest it can be and d needs to be the smallest it can be. So the upper bound for A is the largest possible value of n, which is 4.85, divided by the smallest possible value of d, which is 2.375. This gives me 2.0421 correct to 5 significant figures. This is a much harder question. I'm told this number is correct to one decimal place. So the upper bound is 1.35 and the lower bound is 1.25. I'm told that this number is correct to two decimal places. So the upper bound is 4.605 and the lower bound is 4.595. I'm told x, but in the question I want to use sine x. The upper bound for sine x is sine 30.5. The lower bound is sine 29.5. To work out which one of these is the upper bound and which is the lower bound, I've used a calculator. I've found out that sine 30.5 is 0.507 and sine 29.5 is 0.492. So it's now obvious that sine 30.5 is the upper bound and sine 29.5 is the lower bound. I'm now going to calculate the upper bound. For the upper bound, this needs to be as high as possible and this needs to be as low as possible. So I'm going to use the highest possible value of L, the lowest value of t, and the lowest value of sine x. This gives me this. I then need to work this out using a calculator, giving me this. Finally, I divide to get the upper bound. I've rounded my answer to 3 decimal places, giving me 14.963 as my upper bound. For the lower bound, I want this to be as small as possible and this to be as high as possible. So I'm going to use the lowest possible value of L and the highest possible value of t and of sine x. Typing this into a calculator gives me this, dividing gives me this, and then rounding to 3 decimal places gives me the answer for my lower bound as 12.419. Here's a question for you to try. Press pause and have a go at it. When you're ready for the answers, press play. To find the maximum possible area of paper, I want to have the maximum area for the rectangle and the minimum area for the circle. The upper bound for 15 centimetres is 15.5. The upper bound for 8 centimetres is 8.5. And the lower bound for the radius of the circle is 2.5. To find the area of the rectangle, I need to do 15.5 times 8.5, which gives me 131.75. To find the area of the circle, I need to do pi, which is 3.14, multiplied by 2.5 squared, which gives me 19.625. To find the area of paper left, I need to do 131.75 minus 19.625, which gives me 112.125 centimetres squared. This is my maximum possible area of paper. For the minimum, I need to use the lower bound of 15, which is 14.5, the lower bound of 8, which is 7.5, and then the upper bound of the radius of the circle, which was 3, so the upper bound is 3.5. I need to do the same working out with these numbers. This gives me a value of 70.285 centimetres squared as my minimum possible area of paper left. Now try this question. It's much more difficult and it would be worth 5 marks on an exam. Press pause and have a go. When you're ready for the answer, press play. Here are the answers. If you have these, congratulations, you've managed a really hard question. If you're not sure about them, keep watching the clip and I'll explain how I got them. First of all, I want to look for the upper bound. Speed is distance divided by time. For the upper bound, I want the largest distance and the smallest time. The distance is given in metres, but this is correct to the nearest centimetre, so I need to change it to centimetres. 800 metres is 80,000 centimetres. So here is 80,001 centimetres, and here is 79,999 centimetres. I know my value is correct to the nearest centimetre, and I know I'm looking for the upper bound. So the upper bound is here, which is 80,000.5 centimetres. I'm given the time as 2 minutes, and this is correct to the nearest tenth of a second. 2 minutes is 120.0 seconds. So this is 120.1 seconds, and this is 119.9 seconds. I need the lower bound, which is going to be here, 119.95. Dividing this on a calculator gives me this answer. This is in centimetres per second, but I need to give the answer in kilometres per hour. First of all, I'm going to change the seconds to hours. To do this, I'm going to multiply by 60 to get minutes, and then multiply by 60 again to get hours. I've now got my value in centimetres per hour. I need to change the centimetres to kilometres. If I divide by 100, it gives me metres, and if I then divide by 1,000, it gives me kilometres. Finally, I need to give my answer to 5 significant figures, so my answer is 24.010 kilometres per hour. To find the lower bound, d has to be as small as possible and t has to be as high as possible. Working in a similar manner to the last question, I get the answer 23.990 kilometres per hour.